Thank you very much, Robin, for that introduction. As I was mentioning, I live in Duluth, Minnesota, and we have lots of northern lights here, like you guys do up there. We also see comets, lots of different comets. Like some of the people listening right now, some of you there, you're probably passionate comet observers like myself. I'm not a comet scientist. I should definitely say that at the outset, but I'm just fascinated by comets, and I've observed them for all my life. I started out when I was about 11 years old, and you know how astronomy is. You just can't stop. It's such a very fulfilling hobby. So I've been tracking comets, and I used to keep a list. I had, the last time I look, about 400 different comets that I had observed over the years, and then many apparitions. I enjoy them because they're so changeable. They remind me of people. They're beautiful, they're curious, they do unexpected things. And I like to look at comets from the very beginning when they first appear, when they're at their faintest, all the way through their peak, and then as they fade, because it's almost like hanging out with a friend. You get to see how they evolve and change and flourish and then finally move on. So comets offer a lot of meaningful things about life for me, and I just love them because they're beautiful to look at. I mean, who doesn't just jump up and down when they see a bright comet with a long tail? So we're going to talk about a particular comet this evening. Before I do, we will spend a little bit of time just talking about comets in general, probably things you already know, but just in case. So we'll start with a little bit of background, and then we'll focus in on our primary subject, which is Comet Tsuchinshan-ATLAS. And I apologize to anybody if I mispronounce that. I tried my best. So with that, I'm going to uh, share my screen and go to the presentation. And we started with a lovely photograph. This was taken back in August before the comet got too close to the sun. This was taken by Gerald Raymond, and it shows the beautiful ion tail. That's this tail you here see streaming out. And then here's the dust tail of Comet Tsuchinshan-ATLAS, otherwise known as C2023A3. The last bright comet that we've seen for our area of the world is Comet Neowise, and I like to call it not the virus comet, but the pandemic comet, because it appeared in July of 2020, kind of at that peak time. And I'll never forget, people were so eager to get outside that they filled up this huge rural parking lot one night. And we're just out there marveling at the comet, breathing in the free air. This comet reached about magnitude 1. And in this photograph, which I took on a tracking mount, just a couple of minute exposure, you can see both the dust tail and over here the pale blue plasma or ion tail. This was such a beautiful comet, and it's been a few years since we've had a bright comet. We've had some middling ones that you can see in pairs of binoculars, but that's why I'm hoping that Comet Tsuchinshan-ATLAS will be that next bright one. And there's every reason to believe, at least at this point, that it will. Here's a more recent comet. This is from last year and then all the way up through the middle of this year. We had the return of Comet 12P Pons-Brooks. And it's a beautiful example of what makes comets so fascinating to observe. In the beginning, some of you might recall, it was having these regular outbursts where the comet would go from 16th magnitude, basically invisible, to 12. And you can see some of these outbursts down here along the bottom. Then as it approached perihelion, the outbursts settled down and it grew a couple of very lovely tails. This comet reached about 4th magnitude, so it was very faint with the naked eye, but it was a really pretty sight in a pair of binoculars and small telescopes. Comets, of course, what we see for a comet from Earth is the enormous tail. But a comet is one of the biggest things that's made from virtually nothing. These are all spacecraft images of the actual core or the nucleus or the nuclei of different comets. We have Comet Tempel 1 here, Tempel 1 here. We have Halley on top. Here's Comet Wild. You can see that these are very irregularly shaped bodies because they do not have sufficient self-gravity to crunch themselves into spheres. When people ask me, well, what does a comet look like? I'll say, well, if you've ever dug up potatoes in your garden and you pulled those fresh potatoes out of the ground, that's what comets look like. They're kind of lumpy like potatoes and very irregular. They resemble asteroids in the sense that they're small bodies, generally from 1 to 10 kilometers across. And they're made, what's different primarily is that, at least compared to the inner asteroid belt, the main belt, comets are made primarily of ice with dust mixed in. And the dust can be silicate materials, it can be carbonaceous, carbon-rich organic compounds, clays, things like that. Generally very primitive materials that have been little altered since the beginning of the solar system. As many of you already know, as a comet, this icy body approaches the sun, the ice vaporizes, the technical term being that it sublimes. And in the vaporization process, it releases gas and also dust. Radiation pressure from the sun, the actual pressure of sunlight, the momentum of photons in sunlight, pushes against the dust in the vacuum of space, and it pushes it behind the head of the comet to form the dust tail. Meanwhile, the solar wind and the solar energy itself, sunlight itself, has UV in it, quite a bit of UV light, and that UV light ionizes the gases that are coming off the head of the comet. And one of the main gases that glows when it's ionized is carbon monoxide, of all things. So when you see that blue tail, as you see here in this orbital diagram of a comet, when you see the blue tail, you're seeing basically fluorescing carbon monoxide gas. And the dust tail is slightly curved because it's following along the orbit of the comet, whereas the gas or ion tail is directly opposite the sun. It is blown back from the comet itself, directly opposite the sun, many millions of miles, to form that blue ion tail. It's a plasma tail. So being made of plasma, it's also subject to the whims of the solar wind. And as you probably know, when the solar wind field direction changes, it can snap off the blue tail of the comet, the ion tail, and then another one will grow in place right after. So we have two basic tails that reflect the two basic ingredients of comet, which are ice and dust. I love that dichotomy and how you can clearly see that dichotomy, those different materials, when you get a bright comet. Just a little more detail about comets, give you an idea of sizes. Again, the nuclei are small, 1 to 10 kilometers. The coma can expand with that dust and gas when it's illuminated by sunlight. You see this big fuzzy temporary atmosphere around the comet. That can be 1 million kilometers or more across. The ion tail can stretch for many tens of millions of kilometers, and the dust tail, which is called the type 2 tail, from 1 to 10 million. Of course, these amounts vary depending upon the comet and how active it is. One of the beautiful things about comets, like people, is that they're a little unpredictable. So we have formulae that describe how bright a comet would be, how long we might anticipate the tail to become, but they will confound us, which makes them all that much more fascinating to observe visually, or whether you're into the science of comets. Some of my very favorite comet pictures, of course, were taken by the European Space Agency's Rosetta mission back in 2014 to 2016. It orbited Comet 67P, Churyumov-Gerasimenko. By the way, this comet is the one that really got me into comet observing when I watched it back for the first time in 1982. And I saw changes within the coma, its brightness in the nuclear region. I saw changes in the tail, and I was hooked after that. I had to see every comet I could. There's just two things that I will get up any hour of the night for, and that would be the Northern Lights and to see a new comet. Well, maybe there's 3 things or 4 things. Anyway, so we see these beautiful jets of dust and gas shooting out of the icy core of this comet, which has been eaten away You can see there it's got that narrow neck. It's been eaten away by solar heating over the millennia after its repeated orbits around the sun. Here's an amazing image showing a jet from this comet that when the spacecraft passed almost directly over it. And these jets, comets, the icy surface, that can vaporize or sublime, but the jets form in these cavities deep within the comet that lead to subterranean regions. And as the comet is heated by sunlight, gas in the interior, or ice, I should say ice, I misspoke, ice can vaporize, and then it channels its way through these subterranean tunnels and out these cavities where it's aligned as a jet into space, and all that material shoots out. Of course, those jets can actually affect the comet itself. It can cause it to move slightly in its orbit. So even the position of a comet is not entirely predictable based upon its orbit, because there's different interactions occurring that shift the comet around. The jets can actually alter that. This is my very favorite image of what it might be like to stand on a comet. I call it the blizzard. This is a dust blizzard. It reminds me of a typical blizzard here in Duluth, Minnesota, and probably in your region as well. But we're seeing here is primarily dust and a few cosmic rays taken by the Rosetta spacecraft. And that dust settles on the surface and coats everything. Some of it settles and some of it is lofted, blasted into space to form the coma. And then again, the pressure of sunlight pushes it back to form the tail. No surprise, a comet being made of ice, as it orbits the sun, that ice sublimes and it loses a piece of itself every time. A comet is just sacrificing itself for our joy and wonder at it and for what we might learn. In the case of 67P, for instance, it lost approximately, or loses approximately, a meter of its icy surface every orbit. So that's subliming, that vaporization. There's tons and tons of water coming off the comet every second, and other materials as well. Comets contain ammonia ice, methane, carbon monoxide ice, and carbon dioxide ice as well. Really like this photograph because it shows you in two pictures that were taken several hours apart. You get a sense of the contours of this comet, and so much is happening over time. Those boulders that you see can just roll down slopes because the ice under them vaporizes, gives away, and tips the boulder. Or a jet can shoot out from underneath a boulder and loft it up above the comet and have it fall somewhere else. So this comet, all comets are morphing, changing all the time, subtly in small ways. And we see these changes as changes in the brightness of the core of the comet, which we call the nucleus or false nucleus, and in the tails. Now let's hone in a little bit on one particular comet, our topic tonight, which is Tsuchinshan-ATLAS. It is named for the Purple Mountain Observatory. It's a romanization. Tsuchinshan is a romanization for the words Purple Mountain. So there you have the Purple Mountain ATLAS comet. And it was discovered independently by the ATLAS project, which is the Asteroid Terrestrial Impact Last Alert System. It sounds pretty scary, like hopefully they'll find it before we get hit, but that is a robotic telescope. So the way it was found is interesting. Originally, it was spotted by the Purple Mountain Observatory, recorded as a approximately 19th magnitude object, an asteroidal object at the time of discovery back in January of 2023. It was reported, but then it never got confirmed. And so the comet was lost temporarily until the ATLAS project rediscovered it in February. Whew, thank goodness, right? And then they looked back. At that time, it appeared like an asteroid, but they were able then, based on those observations, to look back at archival observations and determine that it did have a tiny coma, in fact, a very tiny, very dense coma around the false nucleus, the comet itself. And so they confirmed it as a comet, a very faint one indeed. It wasn't too long before we had an orbital calculation, which indicated that, and this happens all the time, every year, many comets are discovered that come from this vast refrigerated region of space that's located 1 trillion kilometers away, even further. It's a very large, roughly spherical region called the Oort cloud. And way beyond the inner solar system, a comet coming from the Oort cloud will typically have an orbital period of millions of years. And that's the case with comet Tsuchinshan-ATLAS. So thank goodness we're all here right now at this time, after arriving at just the right time to be able to see this comet, which has been on its way virtually forever. Just a little bit more about the Oort cloud to give you an idea of where it's located. We have sun, planets, and the sun's influence on its space called the heliosphere. The heliopause, there's Voyager 1 at the heliopause in this diagram. The Oort cloud is beyond all of this. It's between us and the next star system, Alpha Centauri. Although it orbits the sun, it's actually located in interstellar space. So these comets, these are coming, and this particular comet's coming from very far away. This is just a plot of its movement through our solar system to the inner solar system presently and in the next few weeks. It's a little confusing, all those orbits, I apologize. Those green vertical lines indicate above the plane of the solar system, so above the plane of the ecliptic. Blue vertical lines are below the plane of the solar system. Here it is tonight, right there. On its very steeply inclined orbit. Notice that orbital inclination down here, 139 degrees. Pretty outrageous compared to the relatively flat coplanar orbits of the planets. And this isn't a surprise. If we have a spherical cloud of something, when a passing star or perhaps a gas cloud in the Milky Way disturbs the comet out there in the Oort cloud, it falls in from that sphere. So it can fall in at any angle possible. Matter of fact, those incredible variety of angles, of inclinations, is the reason we suspect the Oort cloud is out there and is spherical approximately in the first place, even though no one has ever seen the Oort cloud. So I heard about this comet, and it was too faint, of course, at 18th or 19th magnitude to see it. I had to wait for a number of months. Predictions, though, come in pretty quickly on something like that once an orbit's determined. And it was quickly determined that this could become a relatively bright comet. By January of 2024, this year, I got out one morning, really cold morning. I drove 10 miles north of where I live here, set up my 15-inch. I have a 15-inch obsession reflector and way too many other telescopes besides that. But my main instrument is that reflector, that Dob. And I found it in late January. And even though it was only magnitude 13.5, it was very condensed. I was surprised. I thought, after observing a lot of comets, this could turn into a good comet just based on my own amateur observation, just because of the density of that coma. I thought there's a lot of dust activity there. Well, the comet did brighten fairly rapidly. It went from magnitude 13.5 or so in late January and pushed all the way up to about magnitude 10 in late March and through April. Developed very obvious tadpole-like tail, a prominent coma with a very dense condensation at the center. Of course, we never see the actual nucleus of the comet itself, which is located deep. It's buried deep within that dust. It's much too small, and it's shrouded by the dust that it creates. But it had this tadpole-like shape, and I thought that was kind of peculiar, but it was really bright for being relatively distant from the sun. At that time, it was about 3 astronomical units from us. So I went out and I observed it, and I made this sketch, and I thought, boy, this looks pretty much like the photo. And it really did look like that. I just found it striking that it was like a big old comet, but really teeny tiny, a miniature version of a classic comet. So the comet gradually brightened, as you would expect. It was coming in aiming towards perihelion, so it was approaching the sun. No surprise, the comet was brightening all along the way. And then it reached a point in its orbit from our perspective where it was opposite the sun in the sky. And the opposition occurred on April 18th. This was right about the time that it reached its peak magnitude. And I've written in here over to the left, you can see the comet. Back then it was in Virgo. Way off here to the right, if you can see it, is the sun. So they were almost opposite. So interesting things happen at opposition, like we know. At opposition, you get an opposition effect, right? As a matter of fact, the full moon is basically an opposition moon. And at full moon, because the sun is at our backs, all the rocky surface and dust of the moon, all the shadows that are cast are hidden. And when you hide those shadows, the moon brightens up. So the full moon is brighter than it should be for two reasons. First, because of shadow hiding, which is illustrated in this photograph here, where I'm standing with my back to the sun, and there in the middle where the shadows are hidden, I get a bright spot, right? And then the other is coherent backscatter, which is kind of a technical thing, involves reflection and wavelengths of light of reflection from the materials like dust, and how they kind of combine to create a stronger overall backscattering, reflecting effect towards the observer. So we see this also with the planet Saturn. Maybe some of you have noticed this, called the Zeilinger effect, where before opposition, where the sun is off to one side, Saturn's rings have a typical brightness. But right around the time of opposition, all those little particles, the shadows are hidden, and the rings brighten up. It's actually quite noticeable. If you haven't seen it, I guess we'll have to wait a couple of years, right, for the rings to open, because they're pretty near edge on right now. So, okay, we have the comet gradually ramping up. We hit kind of a peak magnitude. We get a boost, don't we, from opposition. After opposition, the comet begins to fade and kind of plateau out. And some scientists thought that this was cause for concern. This was unusual behavior. And they interpreted this based on the large dust particle size that was observed in this comet. They interpreted this as a potential breakup of the nucleus, this fading, because this will sometimes happen. Other observers and other scientists said, well, wait a minute, we're not seeing those things that show breakup. We think this really has more to do with the fact that the comet is fading because it had a particularly strong opposition effect. And now that it's passed, we're seeing it again from the side. We're losing that coherent backscatter. We're losing the shadow hiding. Not to mention, at opposition time, the comet's tail was tucked behind it from our perspective, which added and further enhanced the brightness. Not fully tucked, but more or less in line. Whereas post-opposition, we began to see the tail stretch off more to the side and lengthen. Here's what the light curve looked like. Here we have January through April, steady rise. This is from Gideon van Buitenen. If you've never gone to his site, which is Bright Comets, and he also does Bright Asteroids, it is a wonderful place full of great up-to-date information about comets and asteroids. But you can see the steady rise here from observations reported to the Comet Observation Database. And then we get the opposition effect. We get a peaking. After that, and I noticed this too as an observer, things just sort of flattened out. But then finally in August, middle of August, it began to rise again in brightness. So it must not have been breaking apart. What we think is we had kind of an opposition effect going on. And in fact, to this day, there's no evidence of disintegration of the comet. Even though I know for a short time it was in headlines all over the internet that it was breaking up, but indeed it is not. Not yet anyway. We hope it stays that way. So everybody was watching this comet. I know I was one of them as long as I possibly could into twilight because I wanted to see what was going to happen, to anticipate what might happen. Is it brightening? Yes, it's slowly brightening now in mid-August as the Earth and the comet, the distance between them shrinks. But by middle of August, The comet basically disappeared from our view into the solar glare just when we wanted to follow it the most, and we couldn't because it dipped too close to the sun for us to see. It was lost in twilight. And this is one of the latest pictures taken of the comet prior to its reemergence in the dawn sky, taken by Australian observer. And the fellow who heads up the comets, the Southern Comets homepage, Michael Matiazzo. Still, we could hold on to the comet. We could continue to follow it, if not from the ground, by using spacecraft. So there was quite a concerted effort to study the images that were taken by NASA's Stereo Ahead spacecraft. So we were able to kind of track the comet for a little while longer into August by using images, granted low resolution images of the comet. And here you can see it. It still has a bright coma, has a tail. It is not falling apart. Good news. When it moved out of the field of view of Stereo A, we could still follow it in the SWAN device, solar wind and isotropies. Oh my gosh, that one's hard, even harder than the name of the comet. And that was in UV light. So we knew the comet was still alive and kicking. But the first person who actually recovered it back on the ground here was Terry Lovejoy, at least to my knowledge. I haven't seen an earlier photo of this, but on September 11th, Terry Lovejoy, who himself has discovered 6 comets, he went out, got a 135 millimeter telephoto lens. The comet was buried in the murk. We know how that is, trying to fish out something from the murk near the horizon. 14 degrees from the sun, he was able to get this image showing the coma, and you can see very faintly here just a little bit of the comet's tail. Just great. Now, as the comet gradually moved away from the sun, for southern observers, for us, as we'll learn in a moment, we'll have to wait until closer to the end of September to see it in the morning sky. And even then, it'll be very, very low. Lovejoy also photographed it several days later. Now you can see it a lot better. We have the tail much more prominent, and its magnitude was 4.8 at that time on September 14th. And this is exactly in line with the prediction for the comet. There's what's called a kind of a baseline comet magnitude based upon our observations and formulas for determining comet magnitude. This one was straight down the middle so far. A great sign, by the way. On September 15th, Michael Matiazzo of Australia photographed it a hair brighter at magnitude 14.6 in a bluing sky at dawn. We will see it now at latitude from here in the Southlands, so to speak, in Duluth at 47 degrees north. I think I might have my first opportunity about September 26th. At latitude 50 and above, it's going to be a little more difficult in the morning. It may really be tough, but it would be worthwhile, especially right at the end of the month, because you've got a moon out there. Okay, we're looking east. To see this comet, it's going to be crucial that you identify in advance a place that has a very nice open view of the eastern horizon. If you can find a lake with an eastern horizon, that's a great place. Thankfully, here in Duluth, I've got Lake Superior, and it's completely open in this direction. So that's where I'll do my observing. At that time, on the 26th, 27th or so, the comet should be magnitude 2. So it will appear about 45 to 60 minutes before the sun comes up. I mean, that is a bright sky. It may be difficult to see except in a pair of binoculars or using a camera. So for more northern Canadian observers, I think you might have a good option here. Maybe your only option would be to see it on the 29th, the 30th, or through October the 1st, low in the sky. And you can use the crescent moon to help guide you toward the comet. Before we take a look at the evening apparition, I want to talk about a distinction between comets. There are comets, I guess in a sense, they're like people again. Some are gassy and some are not. Some are dusty. We had Comet ZTF. You might remember this one from back in the winter of 2023. This was a gas-rich comet. It had a bright greenish blue coma, not unlike the color of my shirt tonight. And of course, this is from C2 emission, diatomic carbon, as we mentioned earlier. And then you can see this dust tail coming out here, and of course, the very straight plasma tail at a different angle, at an angle from the dust tail. Very gas-rich comet. And you can tell because of all of that bright green emission from the gases. Take a look at Comet Tsuchinshan-ATLAS. It is a dust-rich comet. Yes, it has gases. Yes, as you saw in the very first photograph, it does possess a plasma tail, a blue tail. But it is very rich in dust particles. That we have learned since it's been discovered and moved in closer. So that happens to be, given the circumstances of this comet's movement across the sky, that is a very fortunate thing for observers. Dust and other small particulates, they are excellent at scattering light, especially if the light source is between you and the dust or the vapor. Take a look here. This is a bright, look at that little cloud of vapor that you breathe out on a winter morning. The light source is hidden by his head, but you, the observer, are nearly in line. Your line of sight is almost through the cloud to the light. So that cloud is picking up that light and forward scattering it toward you, towards your direction, which makes it appear really, really brilliant. You probably have seen this effect on winter days. The same situation exists with the plumes of Enceladus. Those water plumes, the closer you are to having this, to almost looking right into the sun, the brighter the plumes appear against the background of space, compared to the sun at some angle way over here, or even in back of you. So that is called forward scattering. If you've ever seen the zodiacal light, you probably have noticed that the zodiacal light at dusk or dawn is brighter near the horizon, where you're looking at it almost in the same direction as the sun, right? So you're getting a lot of forward scattering. As you go up the cone, it becomes fainter. You're looking away from the sun. You're not getting that effect. There's another example of forward scattering. It happens all around us in the world. Once you're aware of this property, you see it everywhere. This cloud is just beautiful, lit up by the crescent moon through forward scattering, the water molecules, the vapor in there, the dust, making it just a brilliant and beautiful sight. Well, look at the comet's path. So in late September, all the way through the middle of October, it is passing through the sky approximately in the direction of the sun. Here it is at perihelion. Solar conjunction, it's almost straight in front of the sun. Well, you can imagine that near lineup of the sun and the comet, that boosts forward scattering, the effect of forward scattering. It just sends it skyrocketing. So the comet will be quite brilliant, as we'll learn in a moment, on and around October 9th. Of course, it's also going to be very close to the sun, making it very tricky to see. You will still, some observers, careful observers, will be able to see the comet around this time. Well, I shouldn't make promises, but potentially can see the comet around this time by carefully blocking the sun with their telescopes. And then they might be able to catch a glimpse of a little bright fuzzy spot in the sky. So it could become visible in the daytime. A very similar comet, different in the sense it was a larger one. It cooked up more dust at perihelion and so forth. But Comet McNaught in 2007 became a naked eye, a daytime comet, in large part because of forward scattering, that angle being just right to bring so much light from the sun to our eyes, greatly amplified by forward scattering. Here's how it kind of works in this diagram. The forward scattering amount is determined by what we call a phase angle. And as the phase angle, which is the angle between, let's see if I can get my cursor here, between you, the comet, and the sun, as that phase angle collapses or increases, here it's at 110 degrees, here it's 145, 165. A perfect line of sight would be a phase angle of 180 degrees with an enormous increase in magnitude. This comet will reach a maximum phase angle of 173 degrees on October the 9th. So it will be most brilliant then. But during the whole time from late September through mid-October, the phase angle is quite high. So that will really boost its magnitude by a significant factor. I want to show you forward scattering in action. This is a simulation of the comet. On the right, you see it in the morning sky, then it passes the sun and moves into the evening sky. Watch what happens as it brightens, just how quickly. Just like your breath, just like that foggy breath. Ah, brilliant. And then just as quickly, it will fade. But you've got that brief interval in there. When it's near the sun, so it's going to be low, whether that's morning sky or evening sky, but it's going to be bright. At least that's what we currently predict. Here's some numbers. Joseph Marcus, who is a comet researcher, put all of these numbers together and shared them with me. This is the data from a recent CBET, number 5445, and it shows the date on the left. Over here, oops, sorry. Over here, it's hard for me to read the headings, I apologize. But this is the comet's baseline magnitude. Oh, this is the scattering, the phase angle. You can see it increasing 100, 121. Hits a peak on the 9th of October, gradually decreases. Over here, this is the comet's predicted magnitude, 2.4 on September 29th, 2.2, 2.1. Predicted peak of 2.1. That's without any forward scattering. But here's the forward scattering addition. That is what you add in to the comet's baseline magnitude. And when you add those together, you get the values that are boxed in red on the right. So you can see that this, again, if it doesn't break up at perihelion, you can see that this comet potentially will become rather bright, possibly visible in the daytime sky to careful observers, and definitely a very beautiful sight low in the sky during twilight, morning and evening. So let's take a look at the evening apparition. I've taken those magnitudes, added in the forward scattering enhancement, and put the magnitude next to the date. So this will be our primary time, especially for northern observers, to see the comet at its best. On October 12th, approximately, when it will first appear very low in the west-southwest sky, it will be shining at around minus 1.6. That's pretty impressive. That's actually brighter than Comet Neowise. It will fade to 0.6, 0.2. You can read them up by the 19th. It'll be third magnitude. Not bad. That's still naked eye, right? Fourth, fifth, and so on. So we have a lot of forward scattering. Plus, you have to add another factor in. This will occur during the ideal time. The best time to see a comet is when it swings closest to the Earth right after perihelion. Well, perihelion occurs on the 27th. So the sun is really working over the comet. A lot of dust is being ejected into the coma and into the tail. So you're getting extra dust, and that just boosts the forward scattering. So the timing is ideal. The circumstances, the viewing circumstances are right. But again, the best and brightest views will be when the comet is low. And to keep in mind, there will be moon interference starting about the 15th of October. Darn it, right? You think, great, that curve looks nice, Bob, wonderful. Well, there is going to be some moonlight for an interval there. Won't matter in the early days, like the 12th through the 15th, because it's in twilight, right? So moonlight, not so relevant. But after that, yes, it will make the tail appear somewhat fainter. Now, you guys probably know exactly where to look in the sky, but if there's anyone who doesn't know where to look for this comet and wants to know, I really can recommend Stellarium Mobile. It's a free app for your either phone, whether that be you use Google Play or Apple. Sorry about the misspelling here, but you can use the search feature to locate the comet. The search feature is a little magnifying glass on top. Tap it, type in C2023A3, and it will come up and it will stay there for you. And then you can use that app, hold it against the sky, and you know exactly where to look for the comet at your latitude, because it also picks up on your location. You want to play with it, set the time to simulate where it is at a particular time for your location. Just tap the time at the bottom of the app. And you guys know there's lots of other ways to find things, but this is helpful for beginners. As far as seeing it, I think visually, you're going to have competition from twilight, but the tails, as we'll learn, are expected to grow to 10, possibly up to 20 degrees in length. So I think you're going to be looking in twilight and you'll see a tail and down there a bright star-like head for the comet. But always bring binoculars with you. I find them to be the best instrument. They were fantastic for NEO-wise because they just enhance the brightness that much better and show subtle things in the tails and will reveal, pardon me, the gas tail, which is often the fainter of the two, shows it much better. If you got a pair of 11 by 80s, even better, of course. As far as photography goes, you can try a cell phone. You can certainly set up on a mount and you can do tracking photography. Those would be beautiful images of the comet. All you need will be a telephoto lens to capture this object. Remember, it could be up to 20 degrees from head to top of the tail. So you don't need some fancy long lens or large telescope to photograph it. I have one of these. I use a telephoto lens and a tracking mount, as I mentioned, but I also bought a Sea Star this year, and it is a delightful instrument. You can have it running in the background while you're observing, and it has a field of view of about 1.3 degrees, so it should be great at capturing images of the comet at various times during its apparition, especially in the evening sky. So if you got a Sea Star, go for it. This is a picture of the comet taken with the Sea Star on June 1st. Works splendidly. So how about some more pictures? How about some more recent pictures of the comet? Here's one taken at dawn on the 17th from Australia by Michael again, magnitude 4.3. Notice that it's rising, continues to rise. It's now reached, if it were dark sky, you'd easily see that with the naked eye. Of course, there's a lot of competition from twilight here. So these observers are reporting that it's now easily visible in twilight with a very condensed nuclear region and a faint tail like you see in this photograph. This is from September 18th. The comet has risen to magnitude 4.0 as seen from down under. That tail, you can get a sense here that it's already looking good, right? And we're not even close to its best appearance, in the evening sky. This was taken by Gerald Raymond from a remote camera in Namibia. And it's the most detailed image I've seen of the comet. Here you can see, again, the bright nuclear region, the beautiful dust tail. But look at this, there's a secondary tail down here. Over here, I've I've toned it in a way so the tails are more obvious. This dust tail is made of extremely tiny grains, sub-micron grains of dust. And these types of dust particles usually are given off when the comet gets closer to the sun, like at roughly a 1 AU or thereabouts. So that tail, made of these very tiny grains, is a very recent tail that's developed just in the past couple of weeks. The old tail that we saw back in the spring is this one down here. This is made of the larger dust grains. And our viewing geometry is shifting such that the old tail is coming around to form what we call an anti-tail. It's another tail that's actually just dust that has been dribbled along and left along the orbit of the comet. And from our perspective, that dust forms a spike that shoots out of the head of the comet. So we have the beginning of an anti-tail in comet Tsuchinshan-ATLAS. Let's take a look at this one more time. You will see that the anti-tail will form here as the comet swings past the sun. You may have noticed it the first time too. If you did, I apologize for replaying this, but you can see the gas tail. There's the anti-tail. Stick there. There it is off to the right. It's very thin. It's off to this side. That is dust that was previously deposited by the comet as it's moving along its orbit. So we already have an antitail forming. So here's a comet where we're going to see three tails. There is a gas tail right now, but it's not visible yet because it's still too bright in the morning sky. It blends in with the backdrop. But trust me, it's there. So there are already three tails around Tsuchinshan-ATLAS. But the best is yet to come. The Earth crosses the comet's orbital plane on October 14th and 15th. At that time, we will be looking straight down along the comet's orbit, straight up and down, and the antitail will form this sharp spike that will go all the way up through the middle of the comet and shoot all the way down through the bottom of Tsuchinshan-ATLAS. And it may very well resemble the most famous antitail comet of all, which is Aaron-Rowland in 1957. I'm not old enough to have seen Aaron-Rowland. I was around then, but I wasn't comet crazy in 1957. It was still just a babe. But that one had a very prominent spike, and we expect the exact same thing from Comet Tsuchinshan-ATLAS. Big question in everyone's mind. So far, so good, right? But comets do break up when they get close to the sun. On occasion, they're made of very friable materials. The inside of a comet is so fluffy that if you could hold a piece of it in your hand, if you get your hand in there, get a chunk, you could crush it into dust. It would just crumble. And if you could take a comet and put it on the Earth, it would probably collapse due to the Earth's gravitational pull. Comets are so small, the gravity is next to nothing. And so they can exist just fine being these sort of fragile air chocolate sponges. That's what a comet is. It has a hard surface, but underneath, there's a lot of vacuous spaces, emptiness in there, fluffy ice, as it's called, and dust. So when these comets, especially those from the Oort cloud, maybe this is the very first time in the inner solar system, the sun heats it. Jets can push against the comet, potentially shattering it or fragmenting it. Tidal forces from the gravity of the sun. All of these things can cause comets to fragment, as you see here with Comet C 2019Y4 back in April of 2020. It just broke to pieces. These are Hubble Space Telescope images. That is fascinating to watch too, by the way. So if that happens with this comet, I almost want to say, yeah, that's going to be amazing as well, but I'd rather it stick together. This is Comet Ison back in November, December 2013. The nucleus, we all had these high hopes for this comet, but then due to heating, solar tidal forces, it did swing around the sun. At first, things looked okay, but then it just turned into dust. That was the end. So as far as C 2023A3, don't know yet, but so far so good. That's why we're on this comet. We're sticking with it. Observers are intensely watching it because we want to see it through to the end and beyond. The perihelion occurs on the 27th of September, so that's kind of a big date. It's not a particularly close perihelion. The comet will be about as far as Mercury from the sun, give or take. And then it's closest to the Earth on October 12th. That's when it makes its first appearance in the evening sky. So for my final slide tonight, these are, as I indicated here, these are my hopes and dreams, which is what we as amateurs kind of live on, right? I believe we're some of the most hopeful people on the planet because we believe anything is possible, that the clouds will part even at the last moment. We all are like that. We share that. So we have a magnitude -1.5 comet at dusk in mid-October with 2 or 3 tails, depending upon when you're observing it, a dust and gas tail, 10 up to perhaps 20 degrees long, and then eventually a prominent anti-tail pointing back towards the sun. Will it be Comet McNaught? No, but the same factors are operating here, that forward scattering, and also the timing is right. It occurs after perihelion when it makes its closest approach. So fingers crossed, I think we might be in for the best comet of 2024. And that's the end of my presentation. If you have any questions, I'd be happy to attempt to answer them. Thank you.
Thank you so much, Bob.
Thank you very much.
Wait, when you began, you said you're not a cometary or a comet scientist.
Correct.
I think you are.
Oh, no, no. Don't say
So
that. Don't
gonna
say that
open-
to a scientist.
We're going to open this to questions.
Sure.
Any questions in the room? Yes.
Wondering a bit more about the angle between the tails that she like the ion tail and the dust tail.
The question is the angle between the ion tail and the dust tail as opposed to the anti-tail.
Yeah, the dust tail, the viewing geometry is always changing because the Earth is orbiting and then the comet is swooping by. So you can sometimes see the tails flip-flop one way or another, morning sky to evening sky. Sometimes the two tails from our perspective appear to overlap, but of course they are separated in space. The ion tail will always be exactly opposite the sun in the sky, whereas the dust tail has a slight curve to it because the dust is being dropped off as the comet is orbiting in an ellipse. So I don't know if that answers your question, but that angle will appear to vary both due to perspective and also due to the source or the reason why there are two tails in the first place. Does that help?
It does. I'm getting a nod from Teresa.
A nod. That's always good to get.
That's a good thing. We have another question in the room. So the question is, are there any tricks using your sea star to position the image or to capture an image?
Are there any tricks with the sea star to capture an image? Well, what I do is the sea star has a directory where you can just tap because it will have it has the comet in there, right? So you can just tap the comet's name and then it will find the comet and then you can begin your exposure.
Mhm.
The only issue with the sea star is, at least in the current model, you cannot reorient or tilt the field of view. It is fixed at whatever angle it's fixed at. And so you may not be able to include the entire comet. It might do, you might want a vertical shot of the comet, but it's going to do a horizontal picture for you. So part of it's going to be cut off. They are working on a brand new mosaic mode. I believe it's beta testing right now, where you can do several images on the comet, and then it will assemble it for you, one complete composite image. Do check in the Sea Star group on Facebook. You'll know exactly when, if and when that option is available.
Right. Thank you. I'm just going to add to that, if I may. I would suggest, especially because it's going to be a morning object, use the sky map mode to orient the telescope, so it knows it's already mapped the night sky. Do that when it's dark, so you're prepared for when you're looking for it in twilight. I find my sea star works best when I find some easy objects, and then especially if you're looking for something that's a daytime object like the moon or something like that.
That's a great suggestion. Yeah, you find something bright because you are dealing with a fair amount of daylight, and that can definitely throw the sea star off.
Yeah. And of course, the mosaic mode, I've seen some results of that, where it's stitching pieces together so that you can capture that. What Bob was referring to is the angle of the sea star is going to be fixed. You can't rotate it to capture the comet if it's sideways in your field of view, so you might get the head and miss the tail. But mosaic mode allows you to take multiple images and it'll stitch them together.
And Robin, do you know if that is currently available, or is that still in beta testing?
It's still in beta as far as I know. I haven't.
Okay. Well, in that case, join beta, you can just jump in and do it anyway. My favorite, I will use the Sea Star, but my personal favorite is still when it comes to comets right now is a tracking mount with just a simple telephoto lens. I think this comet will be very nice in a 135 or maybe a two, maybe even a 35 millimeter lens, in which case you can include a scene. You know, you can get a favorite tree or landscape and the comet with the 35 millimeter lens. And given the quality of images taken at high ISOs with today's cameras, you can shoot it at, for instance, like 6,400 or 12,000 ISO. You don't even need a tracking mount. If it is as bright as we're hoping and you're photographing in twilight, you can just put that camera on a tripod, shoot 1/8 of a second, a 30th, maybe 10 seconds, 30, whatever. In other words, you can get it without too much or any trailing. So I'd recommend that too as a possibility.
So I've got another question in the room, and then I'm going to go to Simon with some online questions. Ron. Question is, can you find the comet with a different kind of telescope?
Well, can you can find the, I guess I'm not clear exactly what that means. You can find the comet with, does the person have a telescope already?
This is one of the youngsters in the room. So I like your talk of, about binoculars and then perhaps using that for leads.
Yeah, I think so, Robin. And to the person who, young person who asked, use binoculars first. If you've got that, you're good to go for this comet. If you want to zoom in closer, once you know where to look for it in binoculars, then you can take your telescope, whatever it is, and point it in that direction. And then one thing that's different, okay, the binoculars will show you the color of the tail, it will show you more detail and longer tail. But if you put it in a telescope, you'll see, like, sometimes you'll see these little rays and fans in the tail and other things. So it doesn't matter what instrument you use, they all offer wonderful perspective.
I'm hoping he can get his dad to bring the telescope on the 29th maybe, and his dad has an 18-inch truss tube dub, so yeah, that might be.
Well, that's a nice scope. That should do very well. And of course, those larger scopes will definitely, it's possible that the coma may show some color as well by that time. So we may get that too.
Cool. Okay, let's go to Simon Poole. Simon, you've got a couple of questions I see in the Q&A there.
Yeah, no, thank you, Robin. Have other comets that have broken up all been closer to the sun, or have some comets broken up at greater distance, i.e. farther than 0.4 AU?
Oh boy, I don't know the exact farthest distance for a comet breakup, but they don't all have to be right next to the sun to break up at perihelion. They can break up after perihelion, before perihelion, but well, that's a great question. I couldn't tell you like the largest distance, but yeah, they are that fragile that they can bust up. I remember Comet Elenin, that's another one. And that one broke up before perihelion. We were all watching it brighten, and then because we were still observing it in a dark sky, and then all of a sudden it's broke apart, the nucleus shattered, and it just dissolved away. So they can break up at varying distances. So, but I don't know what the limiting, what the greatest is. Great question.
Just to follow up on that, Bob, how long would it take to notice it being broken up? Is it over a period of nights or hours?
I've noticed it over a period of nights. I've seen a couple of comet breakups, and sometimes what happens is that it becomes brighter temporarily in the nuclear region, but then the next night you look and the nuclear region is gone. It is faded away. And I call them ghost comets. I can't remember the name of the one. It might have been that same one that I showed, but it had a bright nuclear region, nice coma, and then it became like this ghost-like presence. The tail remained, and then there was just the slightest condensation in the center because the pieces had broken and had vaporized away. And then, of course, the most famous one of those is what was the comet Holmes, that, of course, it didn't break up, but comets can have outbursts too, where they don't necessarily break up, but a piece cracks off and fresh ice is exposed. And then you can have a sudden magnitude increase and then gradually it fades. Something like that happened multiple times with Comet 12P Pons Brook. Some of you may have seen it when it was in bright outbursts. It was a dense little ball, and then it gradually expanded and faded. Dense ball again, expanded and faded. It did this maybe half a dozen different times. So it was fascinating to watch. Never completely broke up, but that's how active comets can be. There's intermediate steps, and then there's full breakup too.
Thank you. Let's go to that last question, Simon.
Sure. Concerning annual meteor showers of cometary material, why does the material last so long for the Earth to pass through?
Well, if the comet is continually going around the sun, and every time it approaches perihelion, it's kicking out a lot of dust, right? And that dust circulates and it forms a trail, kind of a ring, like the ring around the bathtub. It forms a trail. It goes around again, there's another trail. So there are multiple trails, and these sort of spread out along the comet's orbit. And as the Earth intersects and passes through that orbit every year for annual meteor showers, then we get pinged. We slam into that material that's been deposited by the comet. Not necessarily the most recent apparition either. We'll sometimes pass through rings of material that were deposited back in the 1500s. And cometary and meteor astronomers can actually pinpoint particular zones and areas that were dropped off centuries ago and tell you, yeah, that was deposited back in the 1580s. And we're going to go through that. So there could be an increase in meteors at that time. Does that answer the question? So it's always cycling about, the comet is refilling it, renewing it, because it's returning to the sun periodically and spewing more dust.
And I suppose the Earth passing through that ring is like cleaning that bathtub ring with your finger. Each time you go by, you're not going through the whole ring, you're just going through a piece of it.
Well, it's so spread out. You may have noticed that a lot of meteor showers, we have a specific date. It'll be like August 12th, 13th for the Perseids, but we're actually in the stream of the Perseids for about a month.
Yeah.
So we only hit kind of the thickest area, at the peak maximum time, but we're in that stream for a while. So it's not maybe the bathtub ring's not so great an analogy, but it's not narrow. It's rather broad. And that's true for a lot of meteor showers. We're often in there for several weeks at a time. It's just that we don't notice them because it might be one meteor or two meteors a night.
Right. All right. Any other questions in the room? Yes, I have one more in the room here. So the question is, would it be worth trying to view the comet after conjunction in the daytime?
Can you repeat the question?
Would it be worthwhile to try and view the comet after conjunction when it's visible in the daytime? Or when it's in the sky along with the sun? Like October 10th, 11th.
Yes, I mentioned that it's there's a particular date that sticks in my mind. This is before conjunction, but on October 7th, for instance, factoring in forward scattering, the comet should be about magnitude minus 2.5, so about as bright as Jupiter. So if you keep the sun out, that comet, it might be visible then on October 7th. I think October 9th, it's so close to the sun, that might be too dangerous to try to see. And then for several days after October 9th, I wish I could go back to my map, but for several days after the 9th, it will still be in the negative magnitude range. And so, yes, I will definitely myself be looking for it when it's to the other side of the sun in the evening sky, to the east of the sun. So look both sides on either side of conjunction. Just be super careful. Make sure no sunbeams enter your telescope when doing so. Or you might be able, some people, what they do is they take a pair of binoculars and they block the sun by using a power pole or a roof line. And if you can efficiently block the sun completely, then you can look right above where the comet's supposed to be and possibly see it in binoculars. I was easily able to see Comet McNaught in the daytime for a couple days in a row when it was about magnitude -5, -6. Super easy in the telescope. And some people saw it in binoculars.
I
Cross
think-
our fingers, we'll get something similar, probably not as bright.
Mhm.
I think somebody's going to recover it in the daytime.
I think I might try it with a sea star. So go under the sun and then with a solar filter and then move off the sun to the comet and then take the filter off.
Yeah, and you could with the, right, you could with the sea star. I believe you could put in on a sky map where it's located or coordinates or something and go there. So yeah, the sea star is really your friend during this comet apparition because you can have it running, taking pictures. Meanwhile, you're standing out there showing people the comet with binoculars or your telescope because this is a great public occasion to get people out to see the sky, which is why it's important to find a place. And for you, I think it might be easier. Correct me if I'm wrong. Make sure you got that flat, wide open horizon,
Mhm.
which we lack here in Duluth because I live in a forest.